In our previous video, we talked about the question 5A in 2023-2024. Now I'm moving to question 5B. In question 5B, what do we have? They said, using the reaction given below, I hope you have a past question with you. They said, explain how each of the following changes in reaction condition will affect the rate of the reaction. We are giving I, solvent change from methanol to DMSO, II, leaving group change from bromine to chlorine, and III, nucleophile change from NOH to what? H2O. So how do we do with this question? We are giving a reaction of this plus this, giving us this and this. So now, before we can determine how this I and III affect this reaction, we need to know the mechanism of the reaction. So we need to know if this reaction is SN1 mechanism or SN2 mechanism or E1 mechanism or E2 mechanism. So let's move straight to the point. So from the equation we have here, we are looking at question 5B. So our equation for the reaction is this guy reacting with what? NaOH to give us this guy OH plus what? NaBr. So what we have here is that when we change what will happen when we change methanol to DMSO, when we change this from what? From bromine to chlorine, and when we change nucleophile from NOH to what? H2O, how will it affect the rate of the reaction? So first thing, what is the mechanism of this reaction? Now from what you notice here, you notice that in this reaction Br is being replaced by OH to give us this product, and we have NaBr. The name of this compound is 1, 2, 3, 4. That is our 3-methyl. We have our 1-bromo 3-methyl pentane. That's our compound. So now we notice that the Br is being replaced by OH, and we have OH in that compound, and we have Br in this Na. So that means that what is happening here is what? A substitution reaction, because we are really having replacement of something. So this is a substitution reaction. So how do we now know if it is SN1 or what? Or SN2? Now one major way of knowing the mechanism is SN1 or SN2 is using of the what? The substrate which is the alkylide. Now you know, if in your knowledge of your whole explanation about SN1 and SN2, you know that what? Our methyl and our primary and our secondary alkylide are going to undergo SN2 reaction, and our tertiary and our secondary undergo what? SN1 reaction. So what type of alkylide is this? Now we need to trace when this the carbon bearing the halogen group. This is it. This is the carbon bearing the halogen group, and the carbon bearing the halogen group is attached to what? To one alkyl. Therefore this alkylide is what? Is a primary alkylide. So since a primary alkylide, therefore it's going to undergo what? Our SN2 mechanism. Do you get that now? When time we have a methyl alkylide, a primary, a secondary, you undergo SN2. And when we have tertiary and secondary, you undergo SN1. And when we analyze this guy, our substrate is the alkylide, you know that this is what? SN1. So SN2 rather, SN2 because it's a primary alkylide. So therefore the mechanism of this reaction is what? SN2 mechanism. Are we together? So now then when we have an idea about this what? About the type of the mechanism in this reaction, then we can now determine the rate of the reaction. If you don't have the idea about the mechanism of the reaction, you can't do anything with all these three. So the first one now, we said when our solvent is changed from methanol to DMSO, you know that what? In SN2 mechanism is favored by what? By polar aprotic solvent, right? It's favored by what? Polar aprotic solvent. And polar aprotic solvent are solvents that don't have hydrogen bonding. Now if you look at it, methanol is a polar aprotic solvent because it has hydrogen bonding, and DMSO is what? Polar aprotic solvent because they don't have hydrogen bonding. So therefore we are changing from polar aprotic to what? Polar aprotic solvent. Therefore that means that SN2 is favored by polar aprotic solvent. So that means that when you are changing this to DMSO, it will favor the SN2 mechanism, the reaction. Therefore the rate of the reaction will what? Will increase. The rate of the reaction will increase. That will be our answer. The rate of the reaction will what? Increase. I believe you are in year 4 now. You should know how to answer question. If I want to answer this very well, I say okay, SN2 is favored by what? By polar aprotic solvent. So therefore methanol is a polar aprotic solvent, changing to what? DMSO, which is what? A polar aprotic solvent. So this will what? Increase the rate of the reaction. Year 4 students should know how to give answer, a detailed answer. So now when you are changing from bromine to chlorine, what happen? You know that what? In the leaving group, bromine and chlorine are leaving group. We have the order of reactivity of leaving group, which is actually, let me rub this up, which is actually our iodine greater than bromine, greater than chlorine, greater than fluorine. This is the order of the reactivity. And notice it, when we are changing from bromine to chlorine, bromine is more as higher order than what? Chlorine. Therefore, when we are changing this in this reaction, based on this order, the rate of the reaction will what? Will decrease. The rate of the reaction will decrease. Let me use my red pen so we can get it. The rate of the reaction will what? Will decrease. I believe you understand. As a year 4 student, you know how to explain this. Bromine has a good leaving ability than chlorine. Therefore, the rate of the reaction will decrease. That is the perfect answer. You get your full mark. Now, the III, we have NaOH to H2O. NaOH to H2O. Now, what happens here is that NaOH is a good leaving, is a good nucleophile, and H2O is a weak nucleophile. Go and read more. Good nucleophile and I said strong nucleophile and what? Weak nucleophile. Go and read on that. So NaOH is a strong nucleophile and H2O is the what? Is a weak nucleophile. Now, based on this reaction, we know that what? This reaction is what? SN2 mechanism, and SN2 mechanism are favored by what? By a strong nucleophile. So we are now changing from strong nucleophile to weak nucleophile. So what will happen? The rate of the reaction will decrease because the weak nucleophile does not favor SN2 reaction. So our answer is the rate of the reaction will what? Decrease. I hope you understand. So anytime you want to solve question on this, you need to first know the mechanism of the reaction, and from the mechanism of the reaction, you can explain how any change you have in the reaction will affect the rate of the reaction.